G max doubles, F min certainly doesn't decrease, it actually increases a little bit. But just by noticing that F min doesn't decrease and G max doubles, this quotient has to at least, and G max doesn't double. G max halves, right? G max becomes half as big. Okay? So we need at least twice as many of these to make this. So our quotient at least doubles. Okay? Again, we shrink this interval to half. Well, this thing's going to shrink to half because it's a linear function. Okay? Because it's a straight line, it's going to shrink down by the same proportion, which means that our G max is going to become half as big. Our F min gets a little bigger, but it certainly doesn't decrease. So if we divide something here that doesn't decrease by something here that becomes half as big, you're going to need twice as many of them, which means that the quotient is going to double. Okay? So we're dividing a smaller G min into a slightly bigger F max. G min is half as much, so it's going to take twice as many of them to make up this. So if we draw this picture, we'd be drawing it with a G max that's half as long. We're going to take twice as many. And then a little bit, okay? Now, what happens if we shrink that interval down to half? Took our original interval around G of x, small interval, shrunk it in half, and our F over G doubled. Shrink that in half, what's going to happen? It's going to double again, isn't it?
Yeah.
Every time you shrink this little interval in half, you're doubling F over G. Okay? So, let's just say it takes 4 of your G max to make your F min on the first picture. So that this value here is 4 times this value, which is very plausible. And also 3, 5, even 6 is plausible. Okay? So let's just take 4, because that's the way it turned out when I drew it. We shrink the interval down half as big. G max gets half as big. F max doesn't get any smaller. F min doesn't get any smaller. So that F over G is now twice as big, right? Then, so if it's twice as big, it was 4. Okay? So what is it after it gets twice as big?
8.
Very good, 8. Okay? We knew that you could do that. Okay. And now we shrink it down half as big again. Okay? Going to be 16 times as big, right? And we shrink it down half as big again.
32.
It's going to be 32, right? Then half as big again.
64.
Well, that's going to be 64. Okay? Next time it's going to be 128. That's going to be 256. It's going to be 512. That's going to be 1,024. That's only with 8 shrinkings. There's no limit to how many times we can shrink this interval. Right? We can keep getting smaller and smaller. 10 more shrinkings, it'll be 1,000,000.
Oh, geez.
Over 1,000,000. 10 more, it'll be over 1 billion.
I stopped listening to you.
Yeah, people usually stop at 1 billion, but you know, our national debt's in the trillions, so you may maybe want to grasp those numbers. So, what's this mean? This means that F over G does what as x approaches this point?
X approaches 0.
Well, as x approaches this 0 of g, this point here. In other words, as we keep shrinking this interval down, what's going to happen to your f over g? Well, it's going to be 4, then it's going to be at least 8, then it's going to be at least 16, pretty soon it's going to be at least 1,000,000, right?
Double.
It keeps doubling every time you shrink the interval down, right? That means that your values of this thing are approaching infinity. Okay? If you keep doubling it, is there any limit to how big it gets?
No.
That's what it means to approach infinity.
Yeah. Gotcha.
Okay? That's also what exponential functions do. This is not an exponential function, but, okay? An exponential function has a constant doubling time. So after, if your investment doubles after 12 years, after another 12 years, it'll double again, then it'll double again. Even if you started with $4, after 8 doublings, it's going to be worth 1,000. After 18 doublings, it's going to be worth 1,000,000. Unfortunately, unless we figure out how to deal with longevity, which would be a problem in itself, you're not going to live that long.
Darn it.
Okay? And money might not be worth anything at that time anyway, but that's how it works. Okay? Well, this is not an exponential function, but if you keep shrinking the interval in half, the values are going to grow exponentially. Okay? Now, what's this mean for the graph?